Alright, so we're going to talk today about, we're going to continue our discussion about ratios and writing out symbolic statements. But we're going to add to that if it's linear or nonlinear. Now, unfortunately, you guys do not get to go to lunch with me every other day for the last 2.5 weeks. And normally from this class we don't usually go anywhere. So I don't have to take you anywhere. But if I ever have to take you somewhere, I'm going to ask that you stand up, push in your chairs, and that you get linear. What do you think it means to be linear? Yes, sir. Straight. Straight what? A straight line. So we're going to talk today about expressions that give us a straight line when we graph them. Now, we're not going to graph them today. Today we're just going to work on identifying, based on simply looking at them, if they are linear or nonlinear. So linear, we've established, means that they are going to be in a what? Straight line. Nonlinear means that they are not going to be in a straight line. Okay? Everybody okay? Alright. Now, the definition of linear is going to sound really overwhelming. It's very mathy. But have no fear, I'm going to help you out. Okay? So, let's start by looking at it. A symbolic statement, all pencils down, all eyes right here. Because you're not going to write this part down. But you're ready. We write it down too. Be ready. A symbolic statement. That's what we've been writing, right? So just like what we did on our homework and just what we did in the bell ringer. A symbolic statement with an X and an equal sign is called a what? Equation. Okay? Each side, the equal sign divides the equation into what? Two parts. There's the left-hand side and the right-hand side. Everybody agree? Those two parts are each called an expression. Okay, so what's on the left is an expression, what's on the right is an expression. Okay? What expressions are made up with is terms. Okay? Expressions have terms in them. Now, when we put those two expressions with an equal in beside it, or in between it, we get an equation. Okay? In a minute, you're going to see a chart. And that chart is going to contain expressions that are linear and expressions that are nonlinear. And based upon the definition, you're going to decide, does it go in a linear column or does it go in a nonlinear column? Okay? Here's the definition. Linear expressions are expressions that are sums. What does that mean? What's the word sums mean? Okay, so we're going to be adding, hopefully, right? We're going to be adding. So sums of constants. Ooh, there's a good word. What's a constant in an expression? Yes, ma'am. A number that stays the same. So that's the first word I want you to write down today. You ready? A constant. All right. Constant terms do not change because of an additional operation. Okay? Constant terms do not change because of an additional operation. So in other words, they're one of those numbers that are just there hanging out by themselves. Okay? Now, real quick, let's talk about what a term is. A term, anybody go on vacation this past summer? Anybody drive on vacation this past summer? Where did you go? Where did you go?
Texas.
All right, beautiful. So let's use Texas as an example. All right, when you left Owensboro and you headed off towards Texas, now I know how I went to Texas, but I don't know how you went to Texas. Where did you go from here? What state did you go to next?
Louisiana.
You can't get straight from Kentucky to Louisiana. So you went down to Louisiana and then over to Texas.
We went to another place.
Where'd you go first?
We're Tennessee.
We're Tennessee. Okay, so you went to Monroe, Louisiana. Okay, now, how did you get to Monroe, Louisiana? You left Kentucky. I'm willing to bet you went on the Natcher. You went to Bowling Green. You got on I-65 and headed south. Where did you go from Kentucky to I-65? What was the very next state you went into?
I was asleep half the time. Yeah.
Where?
Yeah,
Tennessee. Okay. So when you go, I-65 goes straight from Bowling Green, straight down south, runs you into Tennessee. Okay? How do you know when you're in Tennessee?
It smells.
What Tennessee sign? The blue one? And what does that blue Tennessee sign say? Welcome to Tennessee. Okay, and then you probably went from Tennessee, I would be willing to bet, to Alabama.
Yes.
Okay? How did you know when you were in Alabama?
Welcome to Alabama.
There's a big blue sign that says Welcome to Alabama. There's a rest stop there. You pull over. You go see the Welcome to Alabama sign. You see the big rocket ship. Yes. And you get your picture made by the rocket ship, and you get your picture made by the big sign that says Welcome to Alabama. Right?
Yeah.
Okay. And then from Alabama, I bet you went to Mississippi. How'd you know when you were in Mississippi? Big sign says Welcome to Mississippi. How'd you know when you were in Louisiana? Big sign said Welcome to Louisiana, right? And when did you get to Texas? When you saw the what? The big sign that said Welcome to Texas. So we saw a sign. We started in Kentucky. We saw a sign for Tennessee, a sign for Alabama, a sign for Mississippi, a sign for Louisiana, and a sign for Texas. How many signs? How many states was she in? 6. Kentucky, Tennessee, Alabama, Mississippi, Louisiana, Texas. 6 states that she was in, right? Now, terms work the same way. Only when we're looking at terms, there's not a big sign that says welcome to the term, welcome to the next term. But there is an addition sign or a subtraction sign. And when you see that addition or subtraction sign, that's like the big blue sign that says welcome to another state. So if we had 6 terms, okay, we would start, all right, terms, write this down too. Terms are separated by addition and subtraction. Okay? Terms are separated by addition and subtraction. So when you see an addition and subtraction symbol, you know that you're in a new term. Okay? So, they are separated by addition and subtraction, but joined together by multiplication and division. So in other words, you can multiply and divide and be in the same term. But once you add or subtract, you're moving to a new term. Okay? You can multiply and divide and be in the same term. You add and subtract, you're moving to a new term. It's like being in the same county. You can be in Davis County and Warren County. They're in the same state of Kentucky, right? But once you cross that line to Tennessee, you're in a whole new term. Okay? So, your 6 terms may look like this. Okay? Check it out. Started with this term, right? How did you know when you were in a new state? You saw the sign, right? Our sign is not a big blue sign. Our sign is a plus or a minus sign. So boom, plus or minus means new term. There's term 2. Minus sign means new term. Minus sign means new term. These are being multiplied, so they're just one thing together, right? Plus sign means new term. Subtraction sign means new term. So how many terms do I really have here? 1, 2, 3, 4, 5, 6. Yes, the example. So you have 6 terms. Okay, you have 6 terms. Now, let's talk about which terms are constant terms. Okay, if you're not writing, I'm confused as to why. Constant terms are terms that do not change because of an additional operation. Not additional as in adding, additional as in an extra operation. Okay? So, let's look at this. 4. Is 4 got anything else going on? No. So is it a constant term? Yep. It's not changing. It's going to stay 4 no matter what, right? What about 2x? Is it a constant term? No. Because it's going to change because whatever x is going to get multiplied by 2, right? 2 is going to get multiplied by whatever x is. So that's going to change. It's not going to always be 2. What about the -3? Is it going to stay constant? Is there anything that's going to happen to it? Is it going to be multiplied by anything? Is it going to be divided by anything? No. What about the -4x? Is it going to stay constant? Nope, because it's going to get multiplied by whatever x is, right? What about the +3? Is it going to change? Nope. Nothing's going to happen to it, is it? It's going to stay 3 no matter what. But then the -2x, that's going to do what? It's going to change. So is it constant? No. So this one, and this one are all constant, right? Because they're not changing. Everybody okay with that? Those 3 are constant because they're not changing. Now what about the other 3? What are those called? Levi, you think you know?
Yeah.
What?
Non-constant.
Oh, that would make sense, wouldn't it? That's why it's not right. Math, yeah, that would make sense. All right? They're called, those numbers that are with the other ones, those are called algebraic terms because they got the variable, right? And those algebraic terms have what we call coefficients. Okay, algebraic terms have coefficients. Coefficients, what are coefficients? Yes, ma'am. The number beside the x. Okay, so coefficients are numbers in front of the variables. In other words, it's what the variable is being multiplied to. Okay? So, if I've got a positive 2x, what's my coefficient? What number is x being multiplied to? 2. What's my coefficient? -4. What's my coefficient? -2. Okay? So we have terms, which are what make up an expression. We have terms that are constant, and then we have terms that have coefficients. Okay? That's all leading up to linear or nonlinear. Because you got to look at the terms to see if they're linear or nonlinear. Now, somebody in my last class said, wait, it says they have to be sums. And this has subtraction in it. Right? Is that okay?
It's a negative.
Okay? It's okay because we could write that as plus a -2x if we needed to. Right? So it would still be a sum if we needed it to be. Everybody okay with that? Does that make sense? Alright, so it's okay that there's subtraction instead of always just addition. Alright, so it's the sum of the constants. So my numbers that aren't changing. And the product of a constant and an x. So that would be this. That's your algebraic term. Okay? So do we have constants? We do. Do we have algebraic terms? We do. Okay? Here's where you have to be careful. The variable x, in our case, can only be raised to a power of 0 or 1. Okay? So let's write this down. You ready? Can I erase terms over here? Are we good with terms? Okay. So let's look at what this means. Here we go. We good? Okay. So, linear expressions have a variable. Alright, so linear expressions have to have a variable. Okay? What's that variable going to be? Most likely x. Okay? Has to have a variable x whose exponent is 1 or 0. Now, what's an exponent? I know you know this because I know you've been talking about it in PACE. So what's an exponent? Yes, ma'am. The power that it's being raised to, right? So if I have, so here's an example. So x to the first, right? That x is being raised to the first power. Now, how many times in PACE class have you seen an x to the first? Nope. What do you see instead?
X.
Okay, or just x. If it's written as just an x, it's understood that that x has an exponent of 1, right?
Yes.
So it can look like this, it can look like this, or the term could even look like x to the 0. And here's a helpful hint for when you go to PACE class. You ready? This is my helpful hint to make you look smart in PACE. Ready? Anything raised to the 0 power
0.
is what?
1.
Is 1. Okay? So when you go to PACE class and Mr. King says, hey, what's this to the 0 power? It doesn't matter what number it is, how big it is, how small it is, or what letter it is. Anything raised to the 0 power is 1. Okay? So when you're looking at an expression, if it's got a term in the expression that has an x that's got something higher than a 1 as its exponent, it's not linear. Okay? Or if it's got something smaller than a 1, so like a negative number, it's not linear either. Okay? So let's look at our example. All right, you ready? I want you to get your red when ready paper. Okay, red when ready. Listen to me, please. I want you to get your red when ready. All right? Here's what you're going to do. On your red with ready, you can just make a T-chart. Mine wouldn't do just a T-chart. It had to do all the other boxes too. So you can make just a T-chart if you want to. One side that says linear, one side that says nonlinear. Okay? One side that says linear, one that says nonlinear.
Big one or just a small one?
It doesn't matter. You're going to have to write in it, so whatever you want to do. Okay. All right, so one side of your paper says linear, the other side of your paper says nonlinear. Now, let's look at the first one. I want to look at the first one together. Okay, we'll do it together. So here's a term, 5x, right? My other term is a plus 3. Everybody agree? So I've got a term that has a variable. What is the exponent of that variable? A 1. The 5 is the coefficient, right? 1 is the exponent. It's there, but it's not, but we don't really write it. Everybody agree? If there's a 1 right there that we don't really write? So it's got an exponent of a 1. Is this considered linear or nonlinear? Linear. So under linear, you're going to write 5x plus 3. Okay? Now you're going to go to the next one. And you're going to decide, does this expression fall under linear or nonlinear? And you're going to write it on whichever side it goes with. And then you're going to go to this one. Is it linear or nonlinear? And you're going to put it where it goes. Does that make sense? I'm going to give you 4 minutes to put all of those in a column. Okay? 4 minutes to put those in a column. That's all you're doing. You're not solving. You're not working them out. You're just deciding which column do they go in. Do they go under linear or do they go under nonlinear? So you should be deciding linear or nonlinear. And then you have to figure and make sure you know why. got about a minute to finish that up. All right. Now then, here we go. Let's look at the first one. Oh, we did the first one together. Let's look at the next one. Negative 8x plus 7 over 9 minus 3. Linear or non-linear? Linear or non-linear? So, Levi, what do you think? Non-linear, okay? Now, let's talk about what it has to do to be non-linear. In order to be non-linear, it's got to have an exponent other than 1 for the variable, right? Embry. I can't do that right now. Okay, bye. Okay, so it's got a variable, right? So I'll look at the variable. What's the exponent of the variable? 1. Do I have any other variables? No. So is this linear or not linear? It's linear. Okay. What about the next one? Oh, hold on. Sorry, that didn't go. All right. 9x, 9 minus x squared. Chloe, linear or non-linear? Non-linear. How come?
Because it has a 2 as an exponent.
Okay, because it's got an exponent that's a 2. Everybody okay with that?
Yep.
Okay, so that one's going to be what? Non-linear. Does that make sense? Levi, does that make sense? Do you see why this one was linear? Okay. What about 4x squared minus 9? Danielle?
Non-linear.
You said what?
Non-linear.
Non-linear. How come?
It has an exponent of 2.
Because it's got an exponent of 2. Everybody with me so far? Okay. What about the middle one here? 0.31x plus 7 minus 4.2x. Matt?
Yeah.
Okay, tell me.
Is it linear?
It's linear. How come?
It's the exponent of 1.
Okay, this one's got an x. It's got an exponent of 1, right? This one's got an x. It's got an exponent of 1. So it's linear. What about this one? X over 2 cubed plus 1. Zachary, linear or non-linear?
Non-linear.
Non-linear. How come?
Is that
An exponent of
3?
3. All right. Let's look at the bottom one over there. 11 times x plus 2. Wait, is it Jacob? Okay, Jacob, go.
Linear.
Linear. How come? How come?
Because the x is just 1.
The exponent has an exponent of 1. All right, let's look at this one. A negative 6 minus x plus 15 minus 9x. Linear or non-linear?
Linear.
Linear. How come?
Because it has an exponent of 1.
Because it has an exponent of 1. All right, last one. You ready? 7 plus x to the negative 6 plus 3x. I want to call you Bree. Is that right? It's not, is it? It's not Kylie or Kaylee or any of those things. It's not Brooklyn. It's not Samantha, although I think you look like a Samantha. Sarah. All right, Sarah with an H. Okay, Sarah. Linear or nonlinear? Nonlinear. How come? Because there's an exponent of -6. All right, do we all understand how that works? We feel good about it? Anybody get all those right? You put them in the right column? Excellent. Levi, besides that first one, did you get all the rest of them right? No? But do you understand now? Okay, good. Megan, how about you? Did you get them? All right, we good? All right, now, let's look at this one. Very quickly, I want you to clear your red one ready. And based on now what we just talked about, I want you to decide on your red one ready. Listen. On your red one ready, I would like for you to decide. Is this linear or nonlinear? Is this linear or nonlinear? And then make sure you write out why. Linear, nonlinear, linear, nonlinear, and why for both of them. Okay? Linear or nonlinear, and why. Let me know when you're ready. I forgot to set the timer. Let me know when. What's it got to be for it to be linear? The exponent's got to be a what? A 1 or a 0.
Could it be just the variable?
Let me know when you're ready. So what would you consider? What did you do? You asked her for one. You came and got one from here. Okay, I just want to make sure. So what should you do? So what should you do? Not having a marker. You think? Okay, here. Where's your living room? Alright, are we ready?
Yes.
Alright, let's look at number 1. 5x, the quantity, 557 minus x. Emily, linear or nonlinear?
Linear,
Linear, how come?
because the x doesn't have an exponent over 1,
It does have an exponent
and it's 1, but if it was over 1, it wouldn't be.
because it's got an exponent that's a 1, it's not over 1, it's not under 1, so it's right at 1, so it's linear. Okay? Chloe, what about the second one?
It's nonlinear because it has a 2.
Okay, even though it's got the x to the first power here, it's got another term that's got a higher exponent. So that makes the whole thing nonlinear. Everybody okay with that? It's very important that you know why it's linear and why it's nonlinear. Not just one or the other, but why that's the case. Okay? Now, I want you to write this example down on your actual notes for the day. So on your paper,
Give me a erase.
okay, you can erase your red one ready. Yep. Okay. So I want you to write this example down. Less worried about your red one ready and more worried about writing this down. All right. 4 plus 3x to the 5th. Now we're gonna run through a series of questions that I'm gonna want you to be able to answer for every symbolic expression you see. Ready? I think there's only 4 of them. 4 questions. They're really hard questions. So make sure you're writing them down. Ready? Okay. First question that you're going to ask or answer when you look at a symbolic equation. How many terms? Write it down. How many terms? First question. How many terms? Remember, terms are when you see a plus or a welcome to a new term sign. Welcome to a new term sign is a plus or minus, right? Okay? So, welcome to a new term. Who can tell me? How many terms do I have here? Levi. Okay? What term do you start with? 4. So that's 1 term.
2.
And then you see a big plus sign. That's like saying welcome to a new term. And then you see a 3x to the 5th. So how many terms you got? 2. He amended his answer. Okay? So we have 2 terms. Can you handle question number 1? Francesca, I can tell you were a little nervous about my 4 questions. Is question number 1 okay with you? Can you answer question number 1? Okay. She was nervous, I could tell. Okay, yes sir.
Okay, so will multiplication be a term?
A multiplication is not a term because multiplication puts the terms together. The only way you know when you're coming to a new term is when you have addition or subtraction. Okay? Multiplication is within the same state. So it's like a different county within the same state. Okay? All right. So we got 2 terms. Question number 2. Question number 2. I want you to write it down. Which term is constant? Which term is constant? Now, what does it mean to be constant? Constant means that it's not changing because you're doing something else to it. So which term is constant? Kirsten? 4. Very good. 4 is not having anything happening. It's just going to be 4 no matter what. Nothing's being multiplied to it. Nothing's being divided by it. Nothing's being exponented to it, which I don't think's a word, but that's okay. Okay? So 4 is my constant. Francesca, is question number 2 okay with you? Okay, I got another one. You ready? Here comes question 3. Write it down. What is the coefficient? These questions get harder and harder. Okay? Matt, what's the coefficient? 3. How did you know that?
Because the coefficient is
Beautiful. So here's my here's my other term. The term that's got the variable is going to be your exponential. algebraic term. Algebraic terms have coefficients. Okay? So here's my algebraic term. I'll find my variable, I'll look in front of it, and it's a positive 3. So my coefficient is a positive 3. Everybody okay with that?
I have a question.
What?
If wouldn't it be 3x?
Nope. X is a variable, not a coefficient.
Okay.
A coefficient is only the number that's in front of X.
Okay.
Good question. Francesca, honey, question number 3 okay with you? So far, so good? I had you worried, didn't I? Question 4 is the hardest. You ready? Question 4. Linear or non-linear? It's the hardest question I've asked so far. Hold on. Let everybody get a chance to write it down. Linear or non-linear? Danielle, tell us. Non-linear, how come?
Because the exponent is 5.
Because the exponent is 5. Alright? Now, here's the only difference in what you've got to do tonight on your homework. You know how you had to write the symbolic equation in last night's homework? You know what I'm talking about? Well, you didn't actually write it, but you did the night before. You know, like you did in your bell ringer today. You had to write those algebraic equations. Okay? So tonight you've got to write them, but then you have to say which one's, if it's linear or non-linear. You may not even have to answer the other 3 questions. I'm not sure. It's whatever the directions say to do. But it's probably going to ask you these 4 questions. So once you write it, here are the 4 questions. Can you handle that? Okay, so let's look at another example before y'all get rid of it. I'm going to give you 4 minutes, which I don't even think you're going to need 4 minutes to do. Okay? If you need all 4 minutes, you're wasting time. And I want you to answer those 4 questions on your red when ready. Okay? So on your red with ready, you can simply write terms, constant, coefficient, and then linear or non-linear. Okay? That's what I want you to write. Yeah, that's fine. You do not? No. That's why we're doing it on our red when ready. Okay? Red when ready. So let me know when you've got the answer to all 4 questions. How many terms do I have? What are my constants? What are my coefficients? And is it linear or non-linear? Those are the 4 things you're answering. Verbally, you will have to explain why. Okay? Linear or non-linear? Let me know when you're ready. Let me know when you've got all 4. Good job. Let me know when you have all 4 of them. Linear, non-linear, a coefficient, a constant, and the number of terms. When you're ready. You raised your hand. I'm not crazy. You're just showing me. Okay. I'm going crazy. Raise your hand. I'd like to talk to you today. Are you ready? How do I know? Ready? Almost ready? Let's finish this up. Ready? Ready? All right. The majority of us are ready. Here we go. Question 1. Hold on, my clicker's not working. I was going for the dramatic effect. How many terms? Yes, ma'am. Okay. How many terms? 4. The one I start with counts, right? So that's 1, 2, 3, 4. 4 terms. You might. Okay. Next question. Which term or terms is constant? 9 and 6. Okay. Which ones are coefficients? 3 and 7. Linear or nonlinear? Linear. How do you know? Are we good with this? All right, now, hold on. Don't erase the questions. You might just want to erase the answers. You ready? The same question, only this time we're looking at the same example. Only what do I want you to do this time? Simplify. What does simplify mean to do? Make it smaller. How do we make it smaller?
Is it like combining like terms?
Combining like terms. You put the constants together. Put the constants together. And then you put the coefficients together. So when I put the coefficients together, what do I get? 10x. And when I put the constants together, what do I get? 15. So now I've got a new equation. Oh my goodness. Answer the 4 questions. Quickly, 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 quickly. I don't think it's going to take you 3 minutes. Is it going to take you 3 minutes?
No.
It better not take you 3 minutes. Look, we better be done and moving on. Let me know when you're ready. Quickly. Let me know when you're ready.
Wait, why would it be 10 to x?
Why would it be what?
Why wouldn't it be 10 to x?
10 to x. Because this is like saying you have 7 x's. So I've got 7 of them. Right? I've got 7 of them. And then I've got 3 more. So how many do I have total? 10. So 10 x's. Okay?
I thought like you got to
I'm sorry, you thought you were going to have to what?
like the one that's at the one that's always at the top.
The exponent? No, you only put the exponents when you're multiplying. Okay. All right, we ready? How many terms? 2. How many? What are my constants? 15. What's my coefficient? 10. Linear or nonlinear? Linear. How do you know?
Because the 7 is just placed in 1.
The 7 just.
The x is placed in 1.
All right. Erase the 1 power. Everybody good? All right. Erase your red one readies. This is a good one. Oh no. You ready? What does that right there mean?
Multiplication.
It means multiplication. So this whole thing is being multiplied. Agree? Calm down. Everybody agree? So, here's the question. You don't have to write anything down. Raise your hand when you know. Everybody ready? How many terms? How many terms? Be careful here. Sarah. 3. Good girl. Because that multiplication is not like welcome to a new state. What are my constants? 5. What are my coefficients? 9 and 2? 9, 2, and 7? How about 63 and 2? Why would it be 63? Matt? I can multiply the 9 and the 7, and 9 times 7 is really what? 63. So 63 and 2, linear or nonlinear? Non-linear. Love it? Easy enough? Okay, here's what I need for you to do. I need for you to do, wait, stop, don't move until I tell you to. I'm going to need, please stop until I ask you to. When I tell you to, you're going to make sure your red one ready's clean. You're going to put your red one ready back in your binder. Wait till I ask you to, please. You are going to put your paper under Module 4 in your binder. You're going to put up your marker. And if it's a marker that belongs to me, it's coming here. And one person from your general area needs to bring the erasers up. Okay? Putting red one ready up. Notes in Module 4. Markers and erasers